Okay, what we're going to talk about today is all of our operations on functions. And essentially what this is, it's algebra for the sake of algebra. It's saying that if we have two functions, or any number of functions, but we'll start off with two. So if we have two functions, let's call them f and g, then we can add, subtract, multiply, and divide those functions. So the sum of f and g is written as f plus g of x, or f of x plus g of x. And then the difference is written as f minus g, product is f times g, and quotient is f divided by g. Now on these two right here, on the subtract and the quotient, the order does matter. If you think about numbers, 2 minus 3 is different than 3 minus 2. Same thing with dividing. 2 divided by 3 is different than 3 divided by 2. Now we're going to look at these operations of functions in two ways. We're going to look at them what it looks like from a picture standpoint, from a graphical standpoint, and then we're going to do the whole thing again looking at it from an algebraic standpoint. So it says the following properties apply to functions f and g, provided x is in the domain of f and g. So what that means, it means that the two functions must overlap in order to do the operation. So you can only do the operations graphically where the two graphs overlap. Okay? Okay, so it says, let's say we have two graphs. One is f of x and one is g of x, and they each contain points x comma y. We can differentiate between these points by writing it as follows. For points on f of x, we can write them as x comma f of x or x comma y, and then put a little f there to say that these are the points on the f graph. Then we can do the same thing for the points on the g graph. If we are given the graph of f of x and the graph of g of x, we can graph the new function by using their points. Okay, so what we need to do is we need to find some points on the original graphs. Note, the points must have the same x-coordinate. So what you're looking for here is points that line up vertically. Okay, so they have to line up vertically. And then what you do is you leave the x-coordinate alone because you're doing the operation on the function. And remember, f of x and g of x are just like saying the letter y. So for example, if I gave you f of x plus g of x, then the way you find all the points is you take that x-coordinate that you found, and then you add the two y-coordinates, one on each graph, and then plot that new point, and that gives you your new graph. Okay, and then notice again, for subtract, it's f minus g, f times g, and f divided by g. Now on this one, again, notice y of g cannot equal 0. So in other words, on the graph of g, you cannot use any points that look like that because you cannot divide by 0. So we will talk about what happens when that does occur. Okay, so I'm just going to full screen this. Okay, so it says using four colors, graph f plus g of x, f minus g of x, f times g of x, and f divided by g of x. So off to the side here, we have our table. So it's a 3-column table. So just to begin with, those are your x coordinates. So if we just, if I just use erasable ink here just to show you. So this is a point on x comma f of x. This is a point on x comma f of x. The matching point is x comma g of x, x comma f of x, x comma g of x. Okay, so on and so forth all the way down. Okay, so I'm going to start off with the blue, and I'm going to go f of x plus g of x. So again, what you do is you pick 2 points that line up vertically. So in this case, -4 comma -7 and -4 comma -7. And I'm going to add. So my new point will be at -4 comma -14. My next point will be at -3 comma -11, -2 comma -8, and so on and so forth. So if I didn't give you the table, but I gave you the graph, again, what you would do is you would find a point on f and a point on g. Okay, so they each have -4 comma -7, -4 comma -7. Now we go -4 comma -14. So it's way down here. And then the next one, so at -3, we have this point and we have this point. So at -5 and at -6. So again, the points line up vertically. So if I add those 2 points, I get out -11. And again, the x-coordinate's not changing. -2, -8, because again, I take these 2 points and I add them up. And here, take these 2 points and add them up. And I will get -5. If I keep going here, it's going to be 0, -2, and 1, 1. And again here, so this is my f plus g of x. Okay, so now I'm going to do that exact same thing using a different color, but this time I'm going to go f of x minus g of x. So again, you take the 2 points, and this time you subtract the y coordinates. Now again, remember, it's order matters, so it's f take away g. So -5 take away -6 is 1. -3 take away -5 is 2. -1 take away -4 is 3. So if I plot those points on here, so -4, 0, -4, 1, sorry, -3, 1. Sorry, that was a mistake. -2, 2, -1, 3, and so on and so forth. So this one is f minus g of x. F times g. So I'll do this one in green. Okay, so -7 times -7 is 49. 30, 15, 4, -3, -6, -5, 0, and 9. Okay, so I'm going to start right here because otherwise those points are off my grid. So I've got -1, 4, 0, -3, 1, -6, 2, -5, 3, 0, 4, 9. So this one looks something like it's a quadratic. Okay. So just because you start out with line graphs doesn't mean you always end up with line graphs. There actually really is no rhyme or reason to the shapes that you end up with. You just kind of have to take it on a case-by-case basis. Okay, and then the last color I'm going to do here, I'm just going to pick a different color for my pen. I'll go with, I think this is purple. So it's f divided by g. Okay, so -7 divided by -7, -5 divided by -6, -3 divided by -5, -1 divided by -4, 1 divided by -3, 3 divided by -2, 5 divided by -1. Now be careful here. 7 divided by 0 is an error. And then 1 divided by 9. Now if you remember from our last unit right before Christmas, errors on graphs become asymptotes. Okay, so I'm just going to plot these points. So I realize my picture's getting kind of messy here. So -4, 1, and -3, 5, 6, -2, 3/5, -1, 1/4, 0, -1/3, and then 1, -1.5, and then 2, -5. oh, negative 1.5. Sorry, this one's wrong here. Oops. Okay, just hold on a second here. So this point right here should be right here. So 2 comma, so 1 comma negative 1.5. There we go. 2 comma negative 5. And then at 3 we have an error. So what that is here is that's this asymptote. So our line, whoops, our curve goes like this. And then at 4 comma 9 we have a point up here at 4 comma 9. So chances are it's going to be something like that because it's going to be a rational equation. Okay? So that's how we do it graphically. Now, if on the diploma, for example, they gave you the graphs, so they gave you, let's say, the original graphs, and then they drew either the red, the green, the blue, or the purple, and they asked you what operation was done, you would do the same thing. You're going to look for 2 points that line up vertically, okay? And then you're going to look and you're going to go through process of elimination to see if they added the y-coordinates, subtracted them, times them, or divided them. Okay, so let's look at this algebraically now. So it says consider the functions f of x equals 3 root x minus 2 and g of x equals root x minus 5. Write an expression in simplest form for each of the following. So f minus g of x, so again, this means f of x minus g of x. Now what you need to remember is that f and g are representing functions. They're their own separate equation. So I want to take this equation and minus off this equation. So it's very important that you remember you're not minusing off terms, you're minusing off an entire equation. So we've got 3 root x minus 1 root x is 2 root x. And then we've got negative 2 minus negative 5. So that leaves you with a plus 3. And that's it. Now for evaluating, so this might be a good numeric response question, f minus g of 16. There's 2 different ways you could do this. You could go f of 16 minus g of 16. So f of 16 would be 3 root 16 minus 2. And g of 16 would be root 16 minus 5. So you could punch that into your calculator. You end up with 10 minus negative 1, so I think you end up at 11. The other way to do it is we know our f minus g equation. Our f minus g equation is 2 root x plus 3. So what I could do is I could just plug in 16 into that one equation and also get out 11. Now keep in mind with that second method, if you've screwed up the 2 root x plus 3 equation and then you go and plug a number into that, that will create a double error and that could be quite costly. Okay, so what if it's f times g of x? So again, 3 root x minus 2 times root x minus 5. So this is f of x times g of x. So again, employing those skills from Math 20-1. So 3 root x times 1 root x is 3x minus 15 root x minus 2 root x plus 10. So I'm just foiling there. And the reason why this one happened is 3 root x times by another root x gives you that. And then the squared and the square root cancel off. So I've got 3x minus 17 root x plus 10. And then if I wanted to evaluate f times g of 49, again, you've got the 2 options. You could plug 49 into f and times that by plugging 49 into g. Or we can use our equation from up there and just plug 49 into it. But again, remember, if you've made a mistake, it's going to cost you. So 3 root 49 minus 2 times by root 49 minus 5. So that's that. Whereas if I plug it into this, I have 3 times 49 minus 17 root 49 plus 10. And it should give me out the same answer. Let me just get my calculator here. And yes, it does give me out 38. Okay. Okay, let's change up our functions here. So the functions f and g are that, write and simplify an expression for f divided by g, including the domain restriction. So essentially this is just another way of saying this is a rational function. Because remember rationals, you have x's in the top and x's in the bottom. So our last unit right before Christmas. So again, what we do to simplify this is we factor first. So x squared plus x minus 6 is x plus 3 times x minus 2. So the x minus 2's cancel out. So in simplified form, it's x plus 3, but you have to remember to include any restrictions, even if they cancel off. Okay, so again, this type of question, again, it might appear in the rationals section of the diploma, or it might appear in this unit section. It's either one. Okay, so state the domains of f and g, evaluate 3 times fg of 2. Okay, so domain here, so again, these are rationals. So you've got to remember x is real, but x cannot equal 1. And then for the other one, x is real, but x cannot equal 3. Okay? Okay, evaluate 3 times. So it's going to be 3 times f of 2 times g of 2. Okay, so f of 2, so that's 2 times 2 over 2 minus 1 times 2 over 2 minus 3. So that's 4 times negative 2. So that's negative 24. Okay, write an expression for f divided by g. So again, this is what we were just doing. So 2x over x minus 1. So f of x divided by g of x. Now, because both of these are fractional equations, I'm going to write them side by side. So f of x, and I'm going to write it as divided by g of x. I'm going to write it beside it. Whoops, I went too far. So that is x over x minus 3. Okay, so we've got 2x over x minus 1 times x minus 3 over x. Remember, to divide, you change it to a multiply and you flip. So because this is a monomial and this is a monomial, I can actually cancel out the x's. So what I've got is 2 times x minus 3 over x minus 1. Now, for the domain restrictions, okay? It's every denominator that you have at any point, either in the original question or in all of the work. So we've got x minus 1, x minus 3, and the x. So the restrictions are 1, 3, and 0. Okay? Okay, lastly, just going back and circling back to graphing just to finish this up. So it says the graphs of f of x and g of x are drawn below. Determine the domain of f minus g of x. Okay, so again, you can only do operations on functions where the original two graphs overlap. And the reason for that is, remember I said, look, the x coordinate's not changing, right? These are x comma y's on f. These ones are x comma y's on g. Remember I said to do this graphically, you're looking for 2 points that line up vertically. In other words, they have the same x value. So they can only have the same x where they overlap. So if I just kind of drag this guy over to here, they only overlap. They only overlap starting here. So it's all of that one with just from here. Okay, so it says determine the domain of f minus g. So the domain of f minus g will be all the x's greater than or equal to 0. Okay, so in other words, whatever these numbers are. So it doesn't even matter what the numbers are. I'll be able to find 2 points here that line up vertically. I can find 2 points here that line up vertically, 2 points here, 2 points here, 2 points here, 2 points here, and so on and so forth. Now, if we were to extend this question, what if it was an f divided by g? Again, same rule applies. It can only work where the graphs overlap, but you have to remember that g cannot equal 0. So it would still be the domain of x is greater than 0, but right here, where g equals 0, okay, that can't be used. So now it's just going to be strictly greater than 0, not equal to. Okay? Okay, so that is all of our operations. So in the workbook, they cover that as 3 separate lessons. So one on add subtract, one on multiply, and one on divide. So I just picked a few questions from each one for you to go ahead and practice. But that concludes our operations on functions.